Today here on the bench, a Yaesu VHF UHF dual band FN transceiver FT-4700RH, and this radio came in with no transmit on UHF. Welcome to TRX Bench. Okay, so let's go into the video. So I've set it to 430-100 and the radio is receiving, so without any problems. So very low level is going into the radio and still quite nice synod. Everything is nice, so no problem. Okay, so let's try here if we can transmit. So it is set here. You can see I can change it here over. Okay, and so this means it is active. 70 centimeter is active, and now when I transmit, so it is set to low. I mean, you see it is switching into transmit. So we see here our on-air LED, and we see here our power output meter, which is telling us I'm on the air, but radio is not. So there is definitely no output power. Let me switch it to full power. Now it is on full power. Should be around 40 watt or so. Let's see. Nothing. So it is exactly the same. So you see now it is showing here more power, but in reality there is definitely no output power. So it is still, or it is not working as described. Anyways, so let me switch it to 2 meter and let's see if we have output power there. It is now. Let me start with low. 1 second, I have here the wrong connection, and same story. Let's see if it transmits, and yes, it does. So 5.6 watt output power. So 2 meter is working fine. So let me switch here to full power, which is, yeah, it is exactly 50 watt output power, and I see that the radio is modulating, so that is working as well. So microphone seems to pick here my voice, so that definitely means we have a problem on transmit 70 centimeter. Okay, and this radio here has, let me see, has two antenna outputs. So this is UHF and this is VHF here. That means that we have two completely separated main boards or main circuits for UHF and VHF. And therefore, as our UHF is important, let's have a short look onto our schematic for UHF. Okay, and here we have a copy of our UHF main unit. So let me zoom a little bit in. Yeah, because we are working on the output power. We start right here from our power module, and very often we have problems here in our power modules. So I think we start with the driver here, and the pre-driver and the driver, and that is the output stage. But first, let's check if all the voltages are there. Let me see if you can see it here. So we got an information that we should have 8.4 volt here in case of transmit, and here we should have 14 volt, and I believe that here our power module will get 14, so that means 13.8 volt as well. And we should of course have somewhere our switching between, here it is. So we have TX 9 volt, RX 9 volt, ground, and 9 volt. So that will be our first step to check if we have this voltages here for TX, because otherwise our transmitter stage can't work, because minimum here. So if we go over here and follow here along, so we see this here. Can you see it? I hope. So here, this is the line, and you see that the supply voltage here for our pre-driver is on that line, and our driver is on the 14 volt line, which is different to our switching voltage. But anyways, let's check here for our voltages first before we go ahead with anything else. Okay, and I've cracked the radio open, and well, what we see here is here will be our final stage, behind or in this shielding we will have our final stage. And yeah, what is this here? So that looks a little bit odd, and this capacitor here looks also a little bit odd. So I guess we need to see what that is. It looks like that it is a supply. Is it a supply for our fan, maybe? Okay, so let us first take here the lid off, that we have access here to our power amplifier module. Okay, now we have here a free view into our power stage, and yeah, what we can see here, there is another shielding here for our power module, which is underneath. And yeah, this supply here looks really like the supply for the fan, and this is a temperature switch. So when here our power module is getting hot, this will switch through, and our fan gets activated to cool our power module, additional to our heatsink here. Okay, and what have we else? We have, so I've checked it a little bit for you. So this here, in this additional shielding here, in this additional copper shielding, we have our driver transistor, which is a Q19, and we have here our, hope you can see it. Okay, so maybe it's a bit better. So once again, so this here is our driver, and this is our pre-driver. And yeah, as I said, first we want to check if the TX voltage is thus with the switching voltage, and what we want to check as well is if our power module itself will get supply voltage and will get the switching voltage for getting engaged to transmit. And I have found here our connector where we get our TX switching voltage, from our processor unit. So this here is our how is it called? I believe it is the connector 1, I believe, so J01. Anyways, this here is our connector, and what we go and check now, because we know we have ground, we have permanent 9 volt, we have RX 9 volt, and we have TX 9 volt. Then we switch to TX, and that is what we want to check. And let's see that you can see it on my meter screen as well. Okay, so we should be able to see it. So I guess this is ground, and the next one should be permanent 9 volt, and it looks yeah, it is 8.8. It's just fine. And this here is, I believe, our RX voltage, and we should not read anything here, and that is true, because when I now press our PTT we should read 9 volt, but we don't. Why not? I don't know if I have here a good connection, so I have to check it. 1 second. Okay, found the problem. So our radio was not set to transmit on 70 centimeters, so I've changed it here. Now it is set to transmit on 70 centimeter, and once again, so this is permanent, this must be RX, and here is nothing. And now when I press transmit, and here it is, so here it is. And when I now go back, so this here is our RX voltage, and now when I press TX it should switch off, and it does. So only 30 millivolt. So, and if I now release here the PTT, RX should be back, and that is what we can see. So everything seems to be fine here on this connector, which is coming from our MCU. And now let's have a look if we have all the voltages at our power module, and of course here at our pre-driver and whatnot. And let's check our voltages as well at our transistors, and for here our pre-driver, the Q18, we can check it at L14, because we should have access to L14, and we can check it here for our driver at L16. So there we should see our 8.4 and or whatever 14 volt, to be sure that there is not an interruption somewhere here on the board. So therefore we can take our voltages there, and of course we have to check here our power module as well. And I've checked the schematic. Our power module is a M57788M, which is a Mitsubishi RF power module, and we have here our pins, where 1 is our RF input, 2 is the first DC power supply, which means this voltage should come up when we press PTT. Then this here should be, I believe, our permanent power supply, power pin. We have to check it, and 5 is RF output, 4 is third DC power supply. So we're gonna check these pins here because these 3 pins are responsible for our power supply. Okay, and because it is so easy, we can start here with our power module, and pin 1 is RF input. Pin 2, which is this pin here, should be the switched voltage. And let me see, there it is. I show you the meter. Now I'm pressing PTT and you see voltage is coming up. And then we have, of course, our second power supply, which should be, or power pin, which is permanent, and it is. And the next one is permanent as well, according to our data sheet. And have a look, it is. So that means our power supply for our power module is given, so we do not have any problems down there. The same we have to check here with our pre-driver. Let's see, and it is given. Let me show it to you. When I press here my PTT, you see our pre-driver is getting its power. And let me double check where we can test our voltage for the driver, and that is at L16. Where is L16? Let's go down here. L16 is down here, and you cannot really see it, but I'm at L16, and now when I press my power my PTT, so here is our meter, and now I press PTT and you see there is our 12 voltage, should be 14, but I think that is not completely right, that they have written 14 volt. But anyways, it is just fine. So all our components are getting its needed power. So now we can go ahead and test if there is a outgoing signal. Okay, and when I'm saying outgoing signal, I mean the outgoing signal from the stage, from the pre-driver, driver, and of course we know that the power module is not putting the signal out, so we know that there is somewhere a problem. We need to know if the drivers are working, and that means Yaesu was so kind and is telling us that here at the output of our Q18 we should read plus 20 dBm, and at Q19 we should read plus 30 dBm, and more or less 30 dBm is the input to our power module, that at least we can get I don't know, 40, what was it, 45 watt, I believe, will get out of our power module. So yeah, let's start here with our Q18. Okay, and that is an excellent job for our spectrum analyzer. So you see I have set here our center frequency to 430-100, which is of course our transmitter frequency, and at our pre-driver we should exactly read this frequency when we transmit. And I try now to get my probe down to the pre-driver, and let me see what we see. And hey, have a look. So that is 25 dBm, which we transmit here in or from our pre-driver into our driver. Once again, let me show it to you. Where is it? Here it is. So I have tested here this point, so the collector of our pre-driver, and we should read 20 dBm, and we have read 25 dBm, which is just fine. So the driver is, as a pre-driver, is working excellent. Now I'm interested if we get here at pin 1, because that is easy to test. I have a very good access here to pin 1, and that is at least the output here of our Q19, and I should read something around 30 dBm. I mean, I will have a little bit attenuation here by our cap and our coil here. Anyways, it should be around 30 dBm. If we can read 30 dBm, we can be sure that our driver is working as well. Okay, I've adjusted here my analyzer a little bit. So here the upper line is now plus 40 dBm, and we should read here a carrier somewhat around 30 dBm, and that is what I try to pick now here from the circuit. I hope I'm able to get a good connection. So let's see what we have and have a look. So that is approximately 30 dBm. So it might be 28 or whatnot, I don't know. But I'm sure it is more than enough. And funny enough, while I'm talking, you see that our carrier is moving, and that is the FM modulation, what is here now while I'm talking, included into our carrier. So that is telling us, additional to the carrier, that the modulation is working as well. So everything is fine up to here. Okay, and I was down here at pin 1, and we know that our output is pin 5, so that is this pin. The last one is ground, and here the pins in the middle are ground as well. And let me test the output of our amplifier at pin 5 to see if there is an output power. And therefore, let's go back here to our analyzer to see what's really going on down in our circuit. Okay, and if you're doing things like this, be careful. I'm now going to our output stage, and remember, if the radio would working fine, we would see 45 watt or so, and therefore you really need to think about your setup, because you can easily blow your spectrum analyzer, because spectrum analyzer is a very sensitive instrument, so you always need enough attenuators in front of your input to avoid any damage to your analyzer. So be careful. Okay, therefore I press PTT right now, and I'm not at our test point, so I'm right over it, and you see our analyzer is already, I release it, and you see it is gone here, right? And pressing it, you see it is there. Also, I'm not down at the point, the test point. I go now down to the test point, and you see it is not already 0 dBm. and we should read, if it is really 50 watt, then we should read 47 dBm, and we do not already read 0 dBm, and of course it can't work, right? Remember, 0 dBm is only 1 milliwatt, and that is a reason, once again, it is not 0 dBm, and that is 1 milliwatt, and that is clear that we were not able to read output power on our communication tester. So that means our power module is for any reason an attenuator and not an amplifier. So that means we definitely have a problem here with our power module. I mean, we know that there is not enough output power, or that our power module is acting as an attenuator, but beside that fact, our power module is really getting hot. And when I press PTT, I can see that the radio is drawing 5 amps, and I mean 5 amps is quite a lot, and I really can feel that our amplifier is getting really hot. So that means something is going on here in our module. Maybe it is completely toasted, or maybe if we are lucky we can, maybe we can fix it. So let me take off here the shielding, and let's try to get access to our module itself. And therefore, of course, I have to remove here our ground wires, and then I take off here all the screws that I can lift off our shielding here. Alright, and here is our power module. So I've taken it out of the radio, and you see over here our power module we have a plastic housing. So sometimes you can get it off when it is in the radio, but this was so much sealed that I really had to cut off here the sealing around our plastic cover, and now I'm able to lift it off and put it aside, and we can have now a look here at our module. And sometimes we are lucky, and we have here somewhere an interruption, and if we find an interruption, then we may be able to solder it and to fix it. I mean, no guarantee, but sometimes it works. And if we are lucky, we find an interruption, and let's have an inspection with our microscope. Well, on the microscope I was not able to identify a real crack somewhere in here our hybrid module. Maybe some questionable connections, but definitely not completely cracked. So we will try to reflow here our input pins, so they are always questionable. And you see that especially this amplifier, so we have seen in the datasheet that we have 3, so we have here 1, 2, 3, so that our amplifiers, and we have some coils and capacitors and yeah, what have we. So all what you need, and filters and so on and so on. So all what you need to have an RF amplifier, 50 ohm input, 50 ohm output. So you have to adapt these impedances and so forth, and so that is all on a module like this. And sometimes you really have obvious cracks here somewhere in or on here the ceramic. So it is all on ceramic, and we have here some bounded connections. So unfortunately nothing obvious, but we give it a try. So I reflow all of our input pins, and some questionable connections. Maybe we are lucky, but on the other hand, you see this here, it looks like that it got heat, too much heat. So this is how it looks normal, and this looks a little bit shrinked, I would describe it, and maybe that this has died, and then we really cannot help it, but let's try, maybe we are lucky. Okay, so as discussed, I have reflowed our power module, and for test purposes I have put it back here into our circuit. So we really have to be careful because here our shielding is not over it, which has here our temperature sensor to switch in here our fan. So, but what we can do, because I have screwed it down here, so the chassis can cool it for a short while. So that means we are definitely able to test it, and that is what we are gonna do. So now of course I have to connect here our power supply, which has been done now. Okay, now I can switch on the radio, and yeah, so my communication tester is already on, and you hear here our tone. So everything is just fine. So let me go here to our tester. Okay, and here we can see our signal. Alright, and I give a little bit more power here. Okay, so that is already enough. Let me switch out here the annoying tone. Yeah, everything is fine. Okay, so now our radio is set to low output power on 70 centimeter, and now let's test what's going on. So do we have transmit or not? Wow, 5.3 watt. So you can read it here, and we have the right frequency, and you see it is modulating. Wow, so that means our surgery was obviously successful. But let me switch it to full power for a short moment. We can do it, I hope, without jeopardizing here our power module. So simply watch out here to this figure when I press PTT, so I really do not want to do it too long. 42 watt, successful. I would say that is really great, because we all know that when we have to buy a new Mitsubishi power module, it will simply cost $100 or so. Maybe you can buy it in China cheaper, but you never know if you get a fake module, which unfortunately happens very often. So anyways, this is working just fine. So the only thing I have to do, I put back here our plastic housing, and then of course I put here the shielding onto it, and then we can give it back to the old man. Okay, so let me put back here our cover and our shielding, and then we definitely have a final view. Okay, and everything is nicely back in place, and the learning is, even if we don't see cracks under the microscope, it is always worth to reflow minimum you know, the input and output pins, to be sure that there is not somehow an interruption which is so tiny that you even can't see it under the scope. And that is obviously what has happened here to this module. So it is always worse, because you can't lose. Simply reflow it, and you see 50-50% it works. And here we are lucky it works. Alright, so our repair is done, and we are really at the end of this video. So we do not really know if this repair will last forever, but anyways, give it a try. You see that it can work, and you can always buy a new module if you need, but as long you don't, give it a try. Okay, hope you enjoyed the video. Thanks for watching. Catch you next time, and bye.